Hi. So Kentico 9 has just been released, and if you develop with the platform, then one feature that is bound to have caught your attention is the new continuous integration module. In this video, I'll be giving a brief guide to local development using the new CI module. I'll also bring a continuous integration server into the mix. For that, I'll be using TeamCity, which is a fantastic CI server from the folks over at JetBrains. But who is this person rambling at you in an accent that sounds a bit like Liam Neeson? My name is Michael Kincaid. I'm a certified Kentico developer. Online, I go by the nickname Me and My Robot. You can check me out on Twitter at, you guessed it, Me and My Robot. I'm also the CTO of a digital agency in Toronto, Canada called Eccentric Arts. We've been using Kentico for 6 or so years now and have developed well over 100 Kentico solutions. On large projects, our development teams can be as big as 8 people. We know the importance of a well-tuned development pipeline and have been using continuous integration for about 4 years now. There was a lot of interest when we heard Kentico were going to come out with functionality specific to continuous integration. Now it's here, it's time to kick the tires and see what benefits it brings to managing the platform. But before we begin, be sure to check out the webinar that Kentico recorded shortly after the release. This is presented by Mikhail Kadik, who is a platform product owner over at Kentico. This video will explain what continuous integration is. I'm not going to because I mean like that. I'm going to focus more on the sort of getting the development pipeline set up and bringing in something like TeamCity. So, what's the plan for this demo? First, we are going to set up our local development environment. We're going to have a mighty development team of 2 people. This team is going to use the new CI module, so we better get CI working between the developers. Finally, considering we are looking into continuous integration, we are going to want to integrate continuously. So to do this, we will get TeamCity to publish an integrated development build. Introducing developer number 1. She has a local build of Kentico running on her IIS. She has all the code, which she is getting from source control. Developer number 2 has the same setup. He has a local build and is pulling and pushing the code down from the repo. Prior to the new CI module from Kentico, local development meant using a shared database. This was the best way to avoid spending your entire life content staging or exporting and importing object changes from individual databases. This isn't the case with the new CI module. The new module serializes object changes to disk so that they can now be pushed up to the repo and shared with other developers. This allows developers to use local databases. But here we hit our first hurdle. I bet your eyeballs weren't ready for that color change. Apologies if you're watching this in full screen. I'm not a designer, so my color choices might be a wee bit weird. Our connection string is stored in our web config file, and we need to check that file in. You certainly have to do it if you're using a CI server like TeamCity. If we all have our own databases, then chances are we have different connection strings. You certainly don't want to force everyone to have identical setups. Now, the way to get around this is surprisingly easy. So here we are on developer 1's machine. We can see that she's running the website locally on port 32. If we have a look at our web config file, we can see how we can get around the problem of each developer having their own local database and therefore there being multiple connection strings. In the web config file, what we're doing is we're actually pointing through the attribute config source to another file where we're actually going to store our connection string specific to this user. So if we have a look, you'll see connections.config. If I open that, then here is the CMS connection string that is specific to this local machine. As you can see from looking at the solution, that file is not checked in. Connections.config sits on the local machine. We don't check it in because it's going to be different for each developer. Whenever we've got our continuous integration server running, and it's going to be creating an integrated build, then what we'll do is we'll configure that to use web config transforms. So here you can see we've got a web debug.config transform specific to our debug configuration, and we've got one specific to our release. These files are used to configure transformations on the web config file. So here you can see that we're going to replace what we had put down for our connection string, where we were pointing it to the connections.config file. We're going to replace that with this whole block of XML, where we're going to actually provide our CMS connection string, and that's going to point to the database that we're using for our integrated build. If just a tip, if you ever want to see how your transformations are going to run, if you right-click on the transformation and go to Preview Transformation, then you can see here that it's showing how it's doing that transformation. It's replacing connections.config with this entire block. And over here on this Windows 7 build, we have developer 2, and he's running the website on port 1979. Again, we can see he's checked out the project. It brought down the web config file. It's specifying the connection string is going to be in a file called connections.config. So the developer can then put that onto his local system, and within that file put in the CMS connection string that will point to his local database. Each developer now has their own local build and their own local database. It's time to have a look into Kentico's continuous integration module. Here we are on developer 1's machine. If we go to the continuous integration module, which is under configuration, you'll see that really it's pretty simple to configure. There's just one checkbox to enable continuous integration. And then what you're going to do is you're going to serialize all the objects. What this does is it goes through and it serializes all the different objects that are stored in the database, and it puts that into a folder called CI repository, which is under app data. Not all of the objects that are stored in the database are serialized currently, so check out the documentation to see which ones are supported and which ones aren't. But as you can see here, what it's done is it's created a folder for global objects, and then it's created a folder specific to the site that we're using on this project, which is again just a blank site. There's also a file called repository config, and what that lets you do is filter out the objects that you want to actually export. For example, you might want all of the page templates, web parts, page types, but you might not actually want any document content. So this repository config file will let you configure that. So with the Kentico CI module turned on, both developers will get a local copy within app data of that CI repository folder. If we check out the second developer's machine, within app data, you'll see that they also have the CI repository folder. Now, we're not going to add the CI repository folder to our project, so we're not going to include all those files to the CS proj of the CMS app project. There's a lot of files, and it's going to get a bit annoying to have to keep adding them in and tracking them that way. What we do need to do, however, is add them into source control, because this is how we're going to share them from developer to developer. So in here, you'll see that we are adding in the CI repository folder and all of the files that are under there. Let's have a quick demo of making a change and seeing that move from developer to developer. So here I am on the first developer's machine. I'm just going to make a quick change to the layout. Just add some markup. We'll save this. And then if we have a look at source control, we can see that an object under the CI repository folder, and it's our page template, has been modified. So as it stands, we have that change on our local build, but any other developer doesn't yet have that. So we want to commit this change. So just app updating a template, and then push this up to the repo. So if we go over to the second developer's machine on port 1979 and have a look at their page, you'll see that they currently don't have the update, so they need to pull this down from the repo. So if we do a pull, we'll get the updated file, and then if we have a look at our page, you'll see that we still actually don't have the updated object yet. So what we need to do to actually process the changes that we've brought down from source control is we have to run an executable that Kentico developed, and this is named continuous integration .exe, and you use this with a parameter R. It's within the bin folder of the project. It's not on C, but I just couldn't fit that in here. So this developer would run that and get the changes. Likewise, if another developer brought down changes that were contained within the CI repository folder, they would also run the continuous integration .exe program. So if we have a look at the developer who just brought down the changes, you'll see if we browse to the bin folder that we have this continuous integration .exe file. But here comes hurdle number 2. I have to run that file every single time there's a change. What if I don't notice there's been a change in the CI repository folder? Running that continuous integration.exe file is pretty simple, but it is going to get a bit monotonous. One possible way to address this is to actually get Visual Studio to do the work for you. So here you'll see in the properties for my CMS app project, I've actually specified as a post build event that I want to run the continuous integration.exe file. Because really, every time I pull down a new change or changes from the repo, I'm going to want to build my project. And because it doesn't really take that long to run the project, I don't mind this being part of my local build step. So I brought down the changes from the repo. I know I have that page template update, but I'm not saying it because Kentico hasn't had a chance to deserialize that XML and update my database. So if I rebuild my project, then the continuous integration program will run and deserialize that object. And here you have the continuous integration console firing up. You can see it's going to be looking for changes that are in that folder. It goes to restore objects, and thankfully it only restores objects that have changed. So here you can see it's updating our page template. And then we're complete. So if we now browse to our page, we'll see that we have the update. So, hello ma'am. That's pretty much all there is for local development, or rather all I know so far, as I've not had a whole lot of time to play with the new CI module. So what about adding in an actual continuous integration server such as TeamCity? Having local developers in sync is great, but we want an automated build of dev that integrates and tests work committed to the repo and which can be browsed without having to ask a developer to show their local build. Let's just quickly outline how this will work. First, we are going to bring in a CI server. Next, we are going to get it to bring down a copy of the development branch in our source control. This can be done on a trigger, such as someone pushing to the branch or say a nightly build, a scheduled build. The CI server is then going to go through a sequence of build steps or automated magic to create the integrated development build. The CI server can also be used to deploy that build to a target server. So here you can see we have an integrated dev site that we can browse to. So the first step in our sequence of automated magic is going to be to build the solution. Here you can see TeamCity. I've already set up a project for my Kentico 9 where I'm testing the new and shiny, and I have one configuration here for development. If I go in and edit the settings, you'll see that I have it hooked up to my version control. So it's connecting to my development branch. And if we have a look at the build steps and look at the first one, you'll see that we're using MS Build to actually build the project once we bring down the code from the repo. So here you can see our MS Build parameters. I have a parameter in here, for example, for configuration, where on this one, I'm going to target the debug configuration. And what this is going to do is it's going to apply that web.config transformation so that we then change the connection string to point to the database that we know this integrated build is going to use. The next step in our sequence of automated magic will be to transfer the CI repository folder. Now, the reason why we're doing this is that the CI server will get those files from source control, but because they're not actually included in the project, so they aren't listed in the CS proj file for CMS app, when we deploy this integrated build, and for that it'll be through web deploy, those files won't actually end up on the target server. And remember, for this integrated development build, we're going to need them to get there so that we can then run the continuous integration.exe file. So again, our development 1 local site, on that machine, we have a CI repository file or folder. Likewise, for developer 2, we have the CI repository folder. But because web deploy is going to be pushing all the files that it knows about from the CS proj file, they're actually not going to end up here on the integrated development site. So we won't have that folder that we need. So to get around this, we will have another build step, and it's the second one here, which is going to copy the CI assets. And our assets are going to be under CMS app data CI repository. And again, we're getting these files because they're in source control. And what we're going to do is we're going to use this task runner to actually go and deploy those files or push those files off into the target server. Finally, once everything's been pushed over to that target server, we're going to want to run continuous integration.exe there. We're going to need to do this because, again, this is the only way in which those objects can be deserialized and update the database for that integrated development build. Thankfully, there's a build runner for that as well. And what we're going to do is we're going to use webdeploy.exe to actually run the continuous integration exe on the target. So if we look at the configuration for this build step, you'll see that it's just a command line runner. And all we're doing is we're running msdeploy.exe. And by using the run command, we can actually get the target server to run the continuous integration.exe file. Now, I had to do a couple of custom settings here. Namely, I had to up the wait attempts and the wait interval. And this was mainly because the first time you go through and process those objects, it can take quite a while. Subsequent times, it'll only run objects that have changed or that are new, but you might have to play with these settings. There's a few other settings as well that I had to add in, so we'll look at these now. So settings that I had to play around with to get run command to actually be able to fire continuous integration.exe on the target server. Wait attempts, the number of attempts to try, also the interval between those attempts. So I had to play around with these figures really just to try and give enough time for the continuous integration.exe program to finish. So really bumping up the wait interval there was what actually made that work. I also had to authenticate. So username, this was in the domain username format, and then also obviously provide a password. And that user needs to have the necessary privileges on the target server for this command to actually run through web deploy. With the computer name, I first of all tried the network name, but that didn't work. So what did work was then actually using the web deploy URL. So that's the one that ends in msdeploy.xd. You'll know this if you're publishing through Visual Studio, you're probably connecting to that URL as well. So here's my complete command. First of all, in this build runner step, what I'm doing is I'm moving to the web deploy folder where I know the exe file is, and this is again on the build server. And then from here, I'm executing msdeploy.exe, and you can see that I'm specifying that the run command actually hits continuous integration.exe on the target server. So this is where I know I'm deploying it to. I have my wait attempts and my wait interval configured so that I can give continuous integration.exe enough time to run. Then the computer name, you'll see again, it's not the actual name of the box on the network. It is the URL, port 8172 is the default, to msdeploy.axt. And then when I'm calling that, I'm also passing through my authorization credentials of a user that has the necessary permissions to actually go in and actually apply this command and be able to run that exe on the server. And as always, these problems were found out by hitting the run button over and over and over again. So you can see just took a wee while to get it to actually successfully run. A couple of interesting errors, if such a thing can be said about an error. Here's where I worked out that, oh, I need to move the CI repository folder over because I'm trying to run continuous integration.exe. And it's looking for that folder and it doesn't exist. So that's when I knew I had to put in the second build step. And then again, here we can see an example of an error whereby like we're actually calling continuous integration.exe. It's running. We've found it here. We've got it, the CI repository folder moved over. But because of the settings, we're actually not successfully able to get through the processing of the file. So again, the number of waits are set, but the interval's too low, so we're just getting through them all, and then it's erroring out because it's exiting without being able to actually complete it. So here we have our integrated development build, and you can see that it doesn't have the change that we pushed up to source control. So if we go into TeamCity and if we have a look at some of the pending changes, you'll see that here is the commit that we made where we were updating that template, and here is the serialized file for the master page template. So let's run this build, and hopefully whenever it completes, we'll then see that update on our integrated development build. And now we wait. So as you can see, the build's just finished. It's been successful, and we have a look at the history. We now have 2 successful builds. So if we have a look at the integrated development build, and here we have the update to the page template. And again, TeamCity got the latest build from source control, built the project, deployed the project, and moved the CI repository folder over, and then ran the continuous integration.exe file. So all those build steps were automated by the CI server. As you can see from the successful build count of 2, I just got things up and running with the new CI module, local developers using independent databases and also using a CI server such as TeamCity. I'm going to continue to explore possible improvements to the development pipeline. I certainly need more than a few days experience with the new CI module to understand where the bodies might be buried. Hopefully this video helps you understand the setup and possibilities of this great new feature in Kentico 9. Cheers.